So in order to graph these, what I want to do is I want to write it in standard form. So I want this to be a 1. So I'm going to divide everything through the left and the right hand side by 64. So I'm going to get x squared over 16 minus y squared over 4 equals 1. So because it's x squared minus y squared, it's going horizontal. So I can already tell that the vertices are going to be at 4 and negative 4. So my asymptotes are going to be y equals plus or minus change in y, which is 2, because the square root of 4 is 2, over change in x, which is going to be 4 when I take the square root x. So let's reduce that to y equals plus or minus 1/2 x. So my vertices I can already write in are plus or minus 4, 0, because they're on the x-axis. So I'm going to draw my asymptote. It's going to be 1/2 x. Oops, didn't do that very well. And this is 1/2 right here. So I'm going to go, this is an asymptote. And then it's also the negative slope is going to be the asymptote. So my hyperbola is somewhere, 2 branches are over here someplace. So what you can do is you can plug in a value for x to and see what y is to get the exact point, because you don't know whether to put the point right here or right here. So what I do is I'm going to plug in, I'll plug in 5, okay? I don't want to plug in anything in between here and here because I know the hyperbola has to go this way and this way, so that doesn't help me. So I'm going to plug in 5 or 6. You could plug in 10, but you're going to be off the charts. So I'm going to plug in 10 for x, or 6 for x and see what y is. So it's going to be 6 squared over 16 minus y squared over 4 equals 1. So in my calculator, I'm going to solve for y squared. So I'm going to subtract, I'm going to do 1 minus 6 squared divided by 16. So that's going to get rid of that. Then I'm going to multiply that number by negative 4. So that gets rid of this. And then I'm going to take the square root at the end. So it's a square root, and I'm going to get about 2.3 or 2.2. So if I plugged in 6 and I got 2.2, roughly, then if I reflect it over, I'm going to get a negative 2.2 because the hyperbolas are symmetrical. So I could do the same thing. If I plug in negative 6, I'll get positive 2.2 and negative 2.2. So that's how I get another point. So the foci are going to be at, remember foci is going to be c squared equals a squared plus b squared. So in my equation, I have the square root of 20. So c is equal to plus or minus the square root of 20. And remember that the foci are going to be on the x-axis. So my foci are going to be at plus or minus root 20, but I'm going to break that down into 2 root 5, 0. Okay, number 2. Let's do another one. So here, this hyperbola is going up and down because it's y squared minus x squared. So I can tell already that my vertices are going to be on the y-axis at 2 and negative 2. So my vertices are going to be at 0 plus or minus 2. My asymptotes are going to be the y divided by x. So underneath the y is 4, so it's y equals plus or minus 2/3 x. So by graphing the asymptotes, that kind of helps me see the shape of the hyperbola. So y equals positive 2/3. It starts at 0, goes up to right 3, and then down to left 3, down to left 3, and then my negative 2/3. So this is my hyperbola like this. Okay, so my asymptotes I can write right here are going to be y equals plus or minus 2/3 x. So when I graph this hyperbola, I know it's going to open up and be like this, but I don't know if it's going to be thin like this or go all the way this way. So what I need to do is plug in a value for x. So I'm going to plug in x equals 2 and see what y is. So right over here I'm going to write x equals 2 and plug in y squared over 4 minus 2 squared over 9 equals 1. So when I solve in my calculator, I'm going to add 2 squared ninths to this side. So I'm going to do 1 plus 2 squared divided by 9. Then I'm going to take that number, because that get rid of this, and multiply both sides by 4. So that will get rid of this. And then at the end, I'm going to take the square root of that answer. So that is about 2.4. So when I plugged in 2, I got 2.4. So a point's going to be right here. And I got negative 2.4 because it's plus or minus. So that's my part of the hyperbola. And I'm going to do the same thing right here. I'm going to go right 2, down 2.4. So right 2, down 2.4, left 2, down 2.4. And that's how I get my other point. My foci can be found by doing c squared equals a squared plus b squared. So this is going to be the square root of 13. So c equals the square root of 13, plus or minus. But remember, my foci are going to be on the y-axis. So it's going to be 0 plus or minus square root of 13. Okay, number 3. So again, the hyperbola is going up and down. So I'm going to do, my vertices are going to be at 0 plus or minus 4. My asymptotes are going to be at y equals plus or minus, change y divided by x. So it's going to be 4/5 x. So I have my vertices at 0, 4, 0, negative 4. And my slope is going to go up 4, right 5, down 4, left 5, here, and then connect, and then right 5, down 4, left 5, up 4. My foci are going to be at c squared equals a squared plus b squared. So that's going to be 16 plus 25, which is 41, but it's going to be on the y-axis, so it's 0 plus or minus root 41. And then I need to get another point number, or more points on my hyperbola branch. So I'm going to plug in, I'll plug in 4 for x. Actually, I'll plug in 5 for x, because I'm noticing that that would give me an easier number to work with. So it's going to be y squared over 16 minus 5 squared over 25 equals 1. So I'm going to do 1 plus 5 squared divided by 25, and then times that by 16, and then take the square root of it. And I get about 5.7. So if I go over 5, I'm going to go up about 5.7. So I'm going to go left 5, up about 5.7. I'm going to do the same thing over here. Right 5, down about 5.7, and then negative 5.7. So when you're doing the domain and range of a hyperbola, if I look at my blue function, I'm going left to right infinitely. So the domain is going to be all real numbers. So if you write it in interval notation, it's going to be negative infinity to infinity. The range is going to be going from negative infinity, but you're going to stop at the vertex right here. So there's nothing going on between negative 4 and 4. So you can write that as y is less than or equal to negative 4, and y is greater than or equal to 4. Or you can use interval notation and write it as negative infinity to negative 4, including negative 4, in union with 4 to infinity. So remember that these brackets means that it includes it. Okay, number 5. So in this case, the hyperbola is going left to right, okay, because it's x squared minus y squared. So I'm going to find the vertices again, which are going to be underneath the leading term. So the vertices are going to be on the x-axis, so it's going to be plus or minus 5, 0. The asymptotes are going to be y equals the y divided by x, so it's going to be plus or minus the square root of 9, which is 3, divided by the square root of 25, which is 5x. And then x is in your numerator. I should probably write this a little bit better so you can tell that x is in the numerator. So this is going to be 3 fifths x. And then the foci are going to be at a squared plus b squared, so it's 25 plus 9, which is 34, but it's going to be on the x-axis, so it's going to be plus or minus the square root of 34, 0. So if I start graphing this, I have vertices on the x-axis because it's going side to side. My asymptotes are up 3, left 5. Okay, so it looks like this. And then I want to get another point or more points on this hyperbola. So because the hyperbola is not included between here and here, I'm going to plug in, I can plug in 6. I'll just plug in 6. So it's going to be, plug in 6 for x. So it's going to be 6 squared over 25 minus y squared over 9 equals 1. So to solve for x, I'm going to do 1 minus 6 squared divided by 25, because that gets rid of this part. And then I'm going to multiply by negative 9, because that gets rid of this part. And then I'm going to take the square root of that number. And I get about 1.989, so it's 2. I'll say approximately 2. So if I go over 6, I'm going to go up about 2 and negative 2. So that way it helps me complete my hyperbola. So you should show that you're substituting these numbers in. That's how you're getting your other points on your branch. Your domain is, it's not going infinitely side to side. Okay, there's nothing in between negative 5 and 5. So your domain is going to be from negative infinity to negative 5, including that negative 5, in union with 5 to infinity. Or you can also write it as x is less than or equal to negative 5, and then x is greater than or equal to 4. But your range, it's going up and down infinitely, so your range is going to be all real numbers. Or negative infinity to infinity.